Have you ever really thought about the invisible system that basically runs our entire planet? Seriously, it's like a ghost in the machine that tells your phone exactly where you are, it coordinates every single flight in the sky, and it makes sure that video call you have with someone halfway across the world actually happens at the right time. Today, we are going to map that very system, the hidden grid of latitude, longitude, and time.
I mean, stop and think about that. You pull out your phone, you open up a map, and boom, this little blue dot pops up, marking your precise location on Earth. How does it do that? It honestly feels like magic, but it's not. It's actually the solution to one of the oldest and biggest problems in all of human history.
So let's get into it. For centuries, the moment a ship sailed out of sight of land, it was basically lost in a massive blue void. The Earth is a giant spinning ball with almost no unique markers on its oceans. So how in the world could you create a reliable map, or even just tell someone where you are?
Right? It's like telling someone, hey, just turn left at the third identical-looking wave. For early sailors, this wasn't just some interesting puzzle. This was life and death. It was the difference between finding a new trade route or just disappearing into the sea forever. The need for a system was absolutely critical.
And the solution they eventually came up with was just pure genius in its simplicity. If the world doesn't have the landmarks we need, fine. Let's just create our own. They decided to wrap the entire planet in a precise, mathematical, and completely imaginary grid, a system of lines that would give every single point on Earth its own unique address.
So, this grid is built on two simple ideas you probably remember from school: latitude and longitude. Think of them like a team. Latitude, it handles the north-south direction, while longitude takes care of east-west. One tells you how far up or down you are, and the other tells you how far left or right you are. Simple as that.
Okay, so let's look at latitude first. The easiest way to picture these is as horizontal rings wrapping around the Earth, kind of like the hoops on a barrel. The starting point, our 0-degree line, is the equator. You know, the planet's natural belt line. From there, the numbers count up to 90 degrees at the North Pole and 90 degrees at the South Pole. So your latitude number tells you exactly how far north or south of the equator you are.
And then you have longitude. These are the vertical lines, the ones that run from pole to pole, almost like the slices of an orange. They measure how far east or west you are. But this created a whole new problem. See, the equator is a natural, obvious starting point for latitude. But for longitude, there's no natural zero line. It had to be completely invented.
And this was a huge deal. Think about it. Whichever city became the 0-degree line would, for all intents and purposes, become the center of the world's map. So where do you draw that line? And maybe more importantly, who gets to decide? Well, the answer is a really fascinating bit of history that pretty much came down to power and practicality.
So, back in the mid-19th century, nobody, and I mean nobody, ruled the waves like the Great British Royal Navy. For their massive global fleet to navigate properly, they needed one single standard reference map. So, they just made one. And they drew their 0-degree line right through their own Royal Observatory in Greenwich, London. And because their maps and charts were the most widely used in the world, by 1884 an international conference basically just made it official. Greenwich became the prime meridian, the starting line for the entire globe.
Okay, so problem solved, right? We figured out the where. But just as the Industrial Revolution was kicking into high gear, a totally new kind of chaos started to take over. With railroads, people could suddenly travel hundreds of miles in a single day. The problem? Every single town had its own local time, set by when the sun was highest in the sky. A train schedule was an absolute nightmare of constant, confusing adjustments.
And this whole mess came to a head in the year 1883. The brand new Continental Railroad system in North America was facing total gridlock. To stop all the confusion and, prevent crashes, they realized they had to do something really radical. They had to standardize time itself.
And here is where it gets so brilliant. They realized the answer to their new problem was actually hidden inside the solution to the old one. They could use the exact same grid that mapped the world in space to map the world in time. But how would that even work?
The logic behind it is just beautifully simple. It all starts with this number right here, 360. That's the number of degrees of longitude in one full rotation of the Earth.
Then, you just divide that number by the number of hours it takes for that rotation to happen, which is, of course, 24.
So 360 divided by 24 gives you 15, and that is the magic number. It means that for every 15 degrees of longitude you travel across the globe, the local time changes by exactly 1 hour. This simple piece of math is the key that unlocks standardized time for the whole world.
And this just lays it all out perfectly. You take the globe, which is already sliced up by these lines of longitude. You use those lines to create 24 different zones, each one about 15 degrees wide, and just like that, you have the world's time zones, all built on top of that original geographical grid.
Now, of course, the real world is always a little messier than a perfect math problem. If you ever look at a time zone map, you'll see the lines aren't perfectly straight. They actually bend and stretch all over the place to follow country or state borders. It's just for practical convenience, really, so that a single city or region can all operate on the same clock.
So there you have it, a system that was born out of pure necessity for 19th century sailors who were just trying not to get lost at sea, is the very same system that now powers the GPS in your 21st century smartphone, schedules every flight, and basically runs our entire globalized world.
And I think this quote really just nails the big takeaway here. This grid of latitude, longitude, and time, it's not just a tool for mapmakers. You can think of it as the fundamental operating system that allows our incredibly complex, high-speed, interconnected world to even function. It's this quiet, invisible miracle of human ingenuity.
It really makes you wonder, doesn't it? Back in the 19th century, we built an invisible grid to manage physical space and time. Today, we're building all kinds of new invisible systems for data, for communication, for artificial intelligence. So the question I want to leave you with is this: what are the grids we're building right now, and how are they going to shape the world of tomorrow?